Hello and welcome to our demonstration on the Scientific Calculator project. I'm David, and together with my teammates Abel and Demetrius, we've developed a progressive web application using agile methodologies and modern development tools.
Hi everyone, I'm Abel Boama, and today we'll be showcasing our 3 distinct prototypes, explaining our agile development approach, and also demonstrating how we utilize the GitHub and Copilot features throughout our development cycle.
Hello, I'm Demetrius, and I'll be helping you guide you through our development process and the technical decisions we made along the way. Our team has worked collaboratively to create a future-rich scientific calculator that demonstrates progressive enhancement across multiple iterations.
Our project follows assignment 2 requirements, focusing on implementing a scientific calculator with increasingly enhanced functionality across 3 iterations. We'll demonstrate not just the final product, but the evaluation of our software and our development process.
For this project, we adopted a Scrum-based agile methodology with modifications suited for our small team size. Let me show you our project management approach. So basically, we organized our work using a Kanban, which allowed us to visualize our workflow. As you can also clearly see, we also created user stories for each feature and tracked them from to do through in progress to done, which helped us provide transparency and accountability throughout development.
Our sprint cycles were organized into 3 distinct phases aligned with our prototype milestones. For each sprint, we conducted planning sessions where we prioritized features based on the complexity and the value to users. We also held stand-ups via WhatsApp to ensure continuous communication. Here's an example of our daily updates where team members reported on progress, plans, and potential blockers.
An important element of our agile approach was adapting the framework for our team size. We maintained the core agile principles while streamlining ceremonies to maximize productive development time. This flexible approach allowed us to respond quickly to challenges and pivot when necessary.
Our first prototype, which implemented the core calculator functionalities. This version focused on basic arithmetic operations including addition, subtraction, multiplication, and division. So we press go live. And here we go, this is the basic calculator. It was kept very simple at this stage with clear display and functional buttons. So for example, we do 9 times 9, 81, we can clear all, and we do like 800 divided by 16, for example, gives us 50. User stories implemented in this version included from user story 1 to user story 3, covering basic operations, instant result display, and the ability to clear calculations, which it does.
Now, let me show you how we manage this development using GitHub. We started by setting up our repository structure with separate directories for HTML, CSS, and also JavaScript files. Here you can see our initial commits establishing the whole project framework. And for the feature development, we implemented a branching strategy where each feature was developed in its own branch. Now, for example, here's the basic operations branch where we implemented the core arithmetic functionality. Now, once features were completed and also tested, we used pull request for code review before merging into our develop branch. Now this approach ensured that there's code quality, and it also provided us documentation for our development decisions.
Building on our first prototype, our second iteration transformed the basic calculator into a scientific calculator with advanced mathematical functions. We added trigonometric functions like sine, cosine and tangent, logarithmic functions, square root, and power operations. We also implemented support for parentheses to handle complex expressions with correct order of operations. These enhancements fulfilled user stories USO4 and USO5, providing the scientific functionality needed for more complex calculations while maintaining the intuitive interface from our first prototype.
The development of this prototype demonstrated the power of our version control approach, and we also created feature branches for each scientific function. So I'll give you a quick example. Here's the trig functions branch where we implemented sine, cosine, and tangent operations. And we also utilized GitHub's issue tracking to document bugs and feature requirements. Here you can see how we linked issues to specific commits, creating a traceable development history. And our pull request process became more refined during this phase with more detailed code reviews and also discussions. And this screenshot shows a common thread where we debated the best approach for expression parsing. So for our final prototype, we focused on enhancing the user experience with memory functions and also with calculation history. And we primarily used Visual Studio Code as our IDE, which helped us integrate seamlessly with GitHub and Copilot. Extensions like GitLens enhanced our version control workflow by also providing us inline blame annotations and commit history, which made it easier for us to understand code evolution.
Implemented user stories from user story 6 and user story 7, allowing users to store values in memory with MC, MR, M+, and M- functions, and providing access to calculation history just for reference. We've made sure that the design is very responsive and is better at error handling, ensuring that the calculator works on different sizes. So for example, if you zoom out, you can see that will work on different sizes. Okay, now we're going to test it. So we're going to do a simple calculation of 10 plus 5, give us 15. I'm going to save it using M+ feature. Okay, and now we clear it. And as you can see in the calculation history, we have 15 here from our previous calculation. So now we have 15. We can bring it back, we can recall it by pressing MR. So if we press MR, it should give us 15 in the search, in the display I mean. So it gives us 15, and now we can always remember that value. Let me just do another calculation like this. It gives us 450.
For testing, we used Jest integrated with our IDE, allowing us to write and run tests directly from the development environment. This integration of tools created a cohesive development experience that supported our agile approach, enabling quick iterations and continuous feedback. The combination of GitHub for version control, VS Code as our IDE, and Copilot for code assistance formed a powerful development ecosystem.
For testing, we use Jest integrated with our IDE, allowing us to write and run tests directly from the development environment. This integration of tools created a cohesive development experience that supported our agile approach, enabling quick iterations and continuous feedback.
So in conclusion, lastly, GitHub provided invaluable lessons for our version control and collaboration. And the branching strategy, pull request, and also issue tracking created a structured development process that helped us to maintain code quality, while it also helped us again in documenting our journey. And these tools weren't just technical necessities, they also helped us fundamentally shape how we worked together as a team.
We've learned valuable lessons about adapting agile practices for small teams, effective use of version control, and integrating modern development tools into our workflow. These tools will be invaluable in our future software engineering endeavors.
Thank you for watching our demonstration.